Alright, I'd like to welcome you all back to the next video in my lessons in Chapter 6. And you may remember we previously talked about percent composition and how that relates to the law of definite proportions. And that stated that all the percentages of elements in a compound remains constant no matter where you get the compound. So a sample of water in Norfolk County is 11.2% hydrogen and 88.8% oxygen, and that would be the same as water, assuming it's pure, from a different country like Russia or Moscow or the US, etc. Now we're going to take a look at something called empirical formulas, and this is quite powerful because it allows us to start looking at the formulas of compounds based on the percentage composition. And one good application of this would be the world of forensics, for example. So when we look at forensic science, if someone collects a sample at a crime scene, let's say, if it's analyzed, we can determine what the percentage of different elements would be in that sample. One being maybe carbon or barium or hydrogen, doesn't really matter which element. Now, that equipment costs millions of dollars. But we can easily do the math in the lab or in my home, in this case, to show how we can convert percentages to formulas. So what I've got set up here is a little lesson, and basically, as I just said, the empirical formula, I will abbreviate that as EF. It is the simplest ratio of elements in a compound. That's all it is. And glucose is a good place to start because you may remember from previous grades even that glucose has that very famous formula C6H12O6. So it's an organic chemical. It contains three elements, of course: carbon, hydrogen, and oxygen. If we break it down element by element, you can see that the actual formula of glucose is 6 parts carbon to 12 parts hydrogen to 6 parts oxygen. And that's just a ratio in terms of moles. If we divide that by 6, you can see that we easily get the simplest ratio of elements in that compound, which I just mentioned is the empirical formula, and that would be CH2O. Interestingly enough, this is really why we call simple sugars carbohydrates, because they contain carbon and they're hydrated. And of course, the simplest ratio of carbon to hydrogen to oxygen in this compound would be 1 to 2 to 1. So that is a very quick introduction of what empirical formulas are. And we will next look at a specific question that deals with going from percentages of elements, converting that to grams and moles, and determining what the simplest ratio of elements would be in that compound. So this is just a quick little introduction to empirical formula. I hope it helps you out quite a bit, and it will serve as a springboard to our next steps.